Okay, so we got, who's got a calculator here for us, please? Okay, so what I'd like you to do is, to make it easy for you to understand, is 300 by 2, which give you 600, and then we have to multiply this, sorry, that's right, by a factor of 1.67. The magic figure there is 1.67. I'll explain that later. So what we need to do is multiply 600 by 1.67. 1002. Okay, now here we have to do the same. 300, which is normal stocking rate, by 3 by 1.67. 1503. Okay, it's going to be easier for you to write it down. So we have here 300 cows, 600, 1,000, and 1,500, depending on their size and the stocking rate. So again, we can't carry 1,800 or 1,200 cows here. Because of the smaller size, they eat more relative to the size. Now, if you're a cattleman, if I asked you, in your herd, your cows, under poor nutritional conditions, or we have a dry season, or we have problems with nutrition, which cows will be better body condition? The larger frame cows or the smaller frame cows? Everyone gives me exactly the same answer. Everyone sees that. We see it. But we haven't been able to account for that difference. Now I'm going to show you how we do that. And the reason being is that if we know the reason, we can develop other selection criteria that will help us select correctly. Okay, so that's the reason. Now, I will also explain later the body condition score of 2.4 here for a 1,320 pound cow, and exactly the same conditions without even regarding the number of paddocks, which has a positive influence on body condition. Your body condition here, just by changing cow size, will change from 2.4 to 2.9. So I'm going to write that in. I'll explain later how I get that. So I'm going to say 2.9 here, body condition, and 2.9. Only by virtue of the smaller cow. We've just agreed now that the smaller cow has better body condition. So that difference is 20%. So if you'd like to do that calculation, 2.4 multiplied by 1.2. 2.88. 2.9. Okay. Now, a 2.9 body condition, if you go, I've got the figures I've got a graph there for you. You can look at that later if you want to. But there's a relationship between body condition and calving rate. Now, a 2.9 body condition on a score of 1 to 5 is equivalent to 90%. So we have a 90% calving rate here. And the equivalent weaning weight here would be 330 pounds. At 330 pounds, it's equal grass conversion efficiency for a small cow relative to a large cow. So if you multiplied, let's just see if I'm correct here, because I'm thinking in terms of kilograms and translating to pounds and acres. 330 multiplied by 1.67, which is that factor there, should give us this here. 550, yeah. So that is equivalent. So for every kilogram of grass eaten by a small cow, producing a 330-pound calf is as efficient as a larger cow, not producing a 660-pound calf, but a 550, because she takes in less grass. Which in a sense to some people it looks like an advantage, but it's a very big advantage. A disadvantage rather. Okay, so everyone with us, you might not understand entirely how I get to these figures, I'll explain later, but everyone's following the procedure. Okay, now we have 300 cows at 80% calving rate. That gives us 240 calves, is it? The total number of calves at 80% is 240, and 600 at 67%, 0.67. Is that correct? 400?
360. See, what was that?
It's 600 cows at 0.6 multiplied by 0.67.
402.
402. Okay. Okay, and the next one is 1,002 cows at 90%. So it's 900 and something.
902.
902. And the last one is 1,503 multiplied by 0.9.
1353.
1353. Okay, our total weaning weights in total pounds would be 240 multiplied by weaning weight of 550. So one can do that, 240 multiplied by 550.
132,000.
332,000.
132,000.
132,000. And this one would be 402 multiplied by 500. 205.
201.
201,000. I'm going fast, so you'll have time to catch up if you need to write down. So this one will be 902 multiplied by 330.
297, 660.
297? 660.
Yeah.
Okay, and the last one would be 330 multiplied by 1353. 446.
490.
490. Okay. Okay, now we have a total weaning weight. What is the value? I know that different size calves and different size cows per pound live weight probably have different figures in terms of dollars. What would you, let's forget about the differences, let's just get a uniform figure in terms of value per pound for a weaner. How much you pay for a pound? Or how much you get for a pound weaning weight? I need these figures from you. I don't know what they are.
I got $1.20 the other day for 710 pounds. A year.
So how much would that be a pound?
$1.20.
$1.20 a pound?
That was 700 weight.
Okay, $1.20 a pound. Is everyone agree with that? Any
Well, right now, those five weights would be like $1.40, more or less, and the 330 pounders would be more like $1.70 or $1.80.
Okay, well, let's just disregard that. I know, but it's not going to make any difference to the end figure. If it does, then we can come back to it. Otherwise, it's going to complicate matters. So at least
You could use $1.50.
$1.50. Okay. I'm going to put $1.50 there. People are making a lot of money out of cattle. $1.50, that's $3.30 a kilogram. We're lucky if we get $2 a kilogram. Okay. So what we do now is we multiply that by $1.50, please. If you can multiply 132, I suppose I can work it out in my head if I have to. $198,000. Okay, and the next one would be 300,000, is it?
301, 500, I think.
Okay, and the next one, 297,660.
446, 490.
446, 100. 490. And the last one, please. 446, 490.
669, 735.
669,735.
Yes.
Okay, that's our total production under those different systems. Okay, we obviously have costs involved in producing those animals, so we have to subtract the costs. I've asked a lot of people what the direct costs are. Direct costs meaning each additional cow would have an incremental increase in direct costs. So direct costs are proportional to how many cows you have. So if you have 100 cows as opposed to 200 cows, your direct costs will be double that for 100 cows. Now, in terms of, to get a figure that makes sense to us, in terms of your total turnover in a conventional system here, what percent would be, you'd have to subtract there for direct costs? If your turnover is $200,000, what would your cost be more or less in terms of percent? 20%, 30%? Anyone any idea? I've got an idea because I've worked with a lot of people and asked them. It's about 30% of what your total turnover would be.
If you went with $150, it'd be $45,000.
Why dollar?
If you went with $150 a cow.
Okay, that's what you're working at. It would be 45,000.
Yes.
So we've got 25%. Okay, let's work on that. Let's make it easy. So what would be 25? So let's say
35%.
I'll say about 30%.
30.
And the figure you said was 45, is it?
Well,
About 25%. Okay, let's put a figure that's easy to.
30% would be $59,400.
Okay, let's say 50% then. 50,000 as a compromise. 50,000 sounds right? Okay, I've doubled the number of cows here. I've got twice the number of cows. So obviously it'll be 100,000 here. And then I'm going to make another assumption, not to complicate matters. Although we have more smaller cows, we have double stocking rates. So in terms of livestock units, we've doubled. So we are double that. I'm going to double this figure. I'm going to triple it. I'm going to triple that figure to make it easy. If it makes a difference on the bottom line, we'll come back again and recalculate if we have to. So those are the figures. We have doubled the direct costs, and we have trebled the direct costs. So by subtracting those two, we get to a gross margin. So that'll be 149,800, is it? 149? Is that correct? Just do that one for me, please.
519.
Okay, so that's our total gross margin. That's when we've taken the direct costs, subtracted them from the total turnover, total production. Put a different hat on. We're conventional cattlemen now, and we want to see which system is the best. And our objective is maximum profit per animal. Okay, so we're going to look at the total gross margin per cow. So all we have to do is divide this figure by 300. So 150,000 divided by 300 would be 500, is it? 149,800? Let's say 150,000 divided by 300. 500. That's good profit. This one here will be 201,000 divided by 200, is it? By 600, sorry. 201 divided by 600.
335.
Not so good. And this one would be 346,490 divided by 1,000, so it's 346 more or less, is it? And that, I think, will be the same. Just check that. It's more or less that figure. Okay, so if our objective was, as conventionally is, maximum profit per animal, production per animal, then this system here is by far the best. It's got the best figures. So what this means then is that instead of having 300 cows here, let's bring the figure down to 200. And we put this figure up to about 600. And if we only have 100, we probably put that up to about 700 or 800. So what it means is with conventional thinking, the fewer cattle we have, the more money we're going to make. Because our goal is maximum profit per animal. Okay. Now let's look at it a little bit differently from a business point of view, which I'm sure most of you are here to go back home and make more money out of your cattle. Let's divide it by per acre, 1,000. So what we have to do is divide this figure of 149,000 by 1,000, and we get 150. We divide that, we get 201, 346, and 520. A little bit different, very different. So which is the best system then? If we look at it from a logical, economic point of view, then this is by far the worst as opposed to here, and that is by far the best there. Okay, but let's go a step further. We've invested capital in land, we've invested capital in cattle. And let's look at what our return is in terms of that investment. So we've invested throughout in land $3 million, regardless of how many cattle we carry. Okay, that's an investment. In cattle, what would we put a value per pound for a cow, 1,320 pounds? What would the value be?
$1,500. Killer should bring 12.
Okay, well, let's look at 12 then. Okay, so if that's 12, then it's 600 for the other cow. Because we have to, okay. So let's work on a figure of 12. I'm just going to write 1,200 for the bigger cow and 600 for the smaller cow. Okay. Now what we need to do now is we need to multiply 300, the number of cows we have, by $1,200. 360,000. And obviously this will be 720,000, because it's double. And this will be 600 multiplied by 1,000, that's 600,000.
So,
600 multiplied by 1,000. 600 because they're smaller. Okay. Yeah. And 600 multiplied by 1,503. It'll be by 900,000, is it? Rough figure, 900,000. So the total, I'm just going to add that up, will be 3,360,000, 3,720,000, 3,600,000, and 3,900,000. Everyone follow that? Okay, so we see what's very clear is the amount of capital we invested in land and a relatively small amount invested in cattle. If you've got 1,000 acres and you've got no cattle on it, you're not going to make much money. But if you've got 1,000 acres and you've got more cattle on, the more money you're going to make. Okay, so the return, I'm going to talk about return on investment, and that would be your, how we're going to do it is your gross margin divided by the total capital as a percentage. So if someone's ready with a calculator, we need to, the gross margin is 150,000, and we divide that by the total, that's 3,360,000. So Byron, if you do that for us, 150,000 divided by 3,360,000.
50,000.
Yeah, divided by 3.36 million. 4.4. Okay. Well, let's make it 4.5 closest. And this one will be a gross margin of 201,000 divided by this figure here. $5.4. And the next one will be this figure here divided by this one here. 346,000. Excuse me.
1.6, all right.
9, it sounds right. Just check it. And this one here would be that figure. This figure here divided by this figure here.
I think it's 13.3.
Sounds right. Okay, that's a big difference, 4.5%. And what's interesting is that I asked you earlier, what's the most important factor determining profitability? We said reproduction, fertility, which is right in a sense. But here you have a drop in fertility, you have a poorer weaning weight, lower weaning weight, and yet you're making more money. So you're making much more, your gross margin is much higher, and your return on your investment is much more higher. So efficiency of your capital usage is much higher. When you go to these figures here, we combine high stocking rates with high individual production, in other words, good body condition, as it translates into fertility, we go to these very high figures here, 9.6 and 13.3. That sounds a little bit more business-wise than what we have here. Now, what I'd like to do is the calving percentage required. Remember we said calving rate was very important? It is important. Okay. Now let's assume I'm going to take two extremes. I'm going to look at the calving rate required for a 4.5% return and a 13.3% return in the different systems. So here it's 4.5% and here it's 13.3. What calving rate do we require in this system here to get a 4.5% return? It's 80%. What calving rate do you require here to bring 13.3% down to 4.5%? We're already getting 90% calving rate. What calving rate do you require? $35%? Do you have the same return? Is it difficult? How difficult is it to get a 35% calving rate? You have to keep the bulls out. That's how difficult it is. Okay. Now let's look at this. For a 13.3% return, we require 90% calving rate here. Now to bring 13.3 down, or increase 4.5 to 13.3, what calving rate do we require here? I'm asking the question. I need an answer. We're getting a 4.5% return at 80% calving rate. We have to increase calving rate to get a 13.3% return. What calving rate do we require? We have to start producing twins and triplets to be able to get that. So that just brings it all into perspective. Because everyone talks about when you're increasing your stock densities, you're increasing non-selectivity of grazing, etc., is that production does drop. And here you see it very clearly. Production per animal does drop, but if you have more animals, you're going to make much more money. Now, a combination of high stocking rates and inherently good body condition brings you to these very high figures here. So we have two options. Can I just finish and then I'll ask you the question? We have two options. If we go the conventional route, to be able to compete with us when we increase stocking rate, the universities and colleges will have to start doing research and how we can produce twins and triplets without any hassles, no problems. And they also have to weigh 550 pounds to be able to compete. So we have those two options. So which is the easy option? Obviously, to increase our stock densities, increase our stocking rate, and breed cattle and manage cattle for good, inherently high body condition. That's as simple as it is. So what I'd like to do is take you from over here to how we get over there. And with the help of Jaime, we'll do the grazing side, I will do the cattle breeding side. There was a question you wanted to ask?
Yeah, I'm having trouble following the body condition score being a 2.6 to a 2.9 because if I have a body condition score of a 2 or a 3, my breeding percentage is going to be way down. I don't get to see where you do with a body condition score of 2.9 where you get 90%.
No, but this is 1 to 5.
Yeah, one.
So it'd be equivalent of 6 in
It
your.
says over on your sustainable that you have a 2.9%. That's 2 point. Their body condition scores are 2.9.
No, it's on a scale of 1 to 5. 1 being emaciated,
Yeah.
5 being overfed. It's about 3, 2.9 is the middle.
3. Well,
So it'll be in your situation. Or what are you using? What scale are you using?
well, we about a body condition score 5 is where they'll be in their 80 to 90%.
Okay, well this is 5.8.
That's a 5. And 2.9.
5.8. 5.8.
5.0.
Yeah. So the difference, 1 is 1 to 5 scale I use here. You use 1 to 10. So no, 1 to 10, it'll be close to 6 body condition score.
Okay.
5.8.